Hello, I'm Bruce Crawford. I'm from Nashville, Tennessee. I want to show you something that I've come up with. I have a car battery here, which I got from my neighbor who owns a car dealership, and it was bad, so he let me have it. So this is not it's not a new battery. The way it works is I feed DC power into this 24 volt DC motor, which powers this pump. This is a water pump motor from a wash machine, and it spins it and it puts out AC power, which is what this is connected to, showing you the AC power. Then it powers this light here. Then it runs into this transformer. And this is a 24 volts in and 110 volts out. And I reversed it so I can drop the voltage so I can run it through this rectifier, which are diodes. So I can take the AC power, turn it into DC power, and then it can power my battery. So I have a loop here. It's a continuous loop, because as this thing is powered, this is about 8.5 volts, so this is powering this. And this is coming out at about 55, 60 volts of AC. And then it's looping back, and it's run this light, and it's looping back around to this rectifier, diodes, and it's putting out over 12 volts, which is replenishing the battery. Now over here is a DC motor, and you can see the spindle on it. This is the magnet that goes into the water pump, and you have to connect them with the tube. This part right here is bigger than this, so it's it's a little tricky getting this hooked up. This came off of a dishwasher. You can see that they come with these fans on it. It's a real pain to get that off. But the way this works is, look at it like this is an inverter. It's taking DC, turning it into AC, and then powering this, coming back, and it's powering this rectifier, turning it into DC so I can power the battery. Or you can look at this as an alternator on your car, and this is the motor. An alternator produces AC power, and then the way it alternator works, it's got rectifiers on it and all sorts of other stuff to power your car with DC. So what I'm going to do here, I'm going to turn this on AC. I'm going to turn this on DC. And then I'm going to take this and connect it to the machine. It's going to take a while for this to get going. Didn't have it plugged in. You can see here I got 12 volts. This is producing 56 volts, and it's looping. I've also tried using these modules over here. This is a rectifier diagram, and I've tried to use these modules to get it to work, to boost this power up, and it didn't do it. But as you can see, it's powering this system here. Now, what I'm going to do, I'm going to disconnect this here. I'm going to connect it to this motor over here. Let you see that it's producing 8.4 DC into the motor, and it's producing almost 55 volts of AC, which is powering the light, which is going through the inverter, the transformer, back into the inverter with your diode set up like this over here to run the battery. So it's basically a self-running device, which in the law of thermodynamics, this is not possible. What I'm going to do, I'm going to cut this off. I'm going to show you this first. I'm going to turn the light off. You can see now it's producing almost 80 AC, and the battery is now powering this motor, and you're getting almost 10.8 volts. We'll connect this back to the rectifier, the DC part of it. You see that it's producing 12 volts, 0.12, which is, going around, but it's not drawing any power off of this. But it's getting now almost 80 volts of AC. So now I'm going to turn the light back on. Of course, it's a bad light. You can see where the burnt spots on it. And it'll take a while for it to kick up. And then you see the voltage go up. This is about almost 12 volts. But there again, this is only putting out, drawing up 8.4 volts. So it's just going around and around. I need a better battery. This is a cranking battery. You don't want to get, you want a good lead acid battery. There's a lot of them out there, but I'm just trying this out. You don't want to get a lithium iodine battery because those things will burn up. I was watching Channel 4 this week, and a guy plugged in his e-bike, which is an electric bicycle, in his garage so he could charge it up so he could go ride it the next morning. Well, it caught on fire and burned his house down. So, you don't want one of those. So anyway, and really what I need is 24 volts, 2 batteries, so I can control the voltage on it. But you don't, I'm going to show you when I cut this off, you don't want the voltage going over 13. So what I'm going to do, I'm going to cut the video, I'm going to re-hook it up, and then I'll be right back. Alright, do a recap here. You have the motor here. It's going to be powered by this DC controller. You plug it into the wall and you can turn the voltage up to 24 volts of DC. To power this, to power the water pump, washing machine pump that produces AC, which will power this light, which will run it through the transformer to decrease the voltage to bring it back into the rectifier, which are the diagram here of the diodes, how you have it hooked up. And I'm going to show you how much power this motor will produce. So I'm going to turn it on. Okay, 10 volts. I don't have the light on. I'm producing 77 volts. I'm getting almost 15 volts DC out of my rectifier. Alright. Now 15 volts, I'm getting 23 volts of DC. Okay? I'm getting 116, almost 117 volts AC out of this motor. Okay? Now I got 20 volts going in. I got 31 DC. I got 156 AC coming out of this. And I ain't got the light on yet. I'm just showing you how much this little generator can produce. I'm going to turn it up all the way. I'm getting 39 DC, 188. Now I'm going to turn the light on. See how the voltage dropped? This went down a little bit. That's 24 volts. But I don't need 37 DC to power that battery. So I'm going to turn it down. At 18 volts, I'm getting 118 AC, 26 out of this. So that's why I'm running that 10 volts off my battery so I can charge the battery and have a continuous loop. I'm just showing you this, how much of AC power this device can use. I'm going to cut this off because it's making a lot of noise. Cut this off. Well, you could take this out in a camper. You know, you're going camping, you want some lights. But what needs to be done is like Governor Bill Lee of Tennessee, he could have his company, Lee and Company, they could put one of these together in a day and start doing some experimenting on it. You know, they probably got a lot better equipment than I got. Now, the windings on this water pump are real thin. They could be bigger. You can make this bigger because all it is steel cord. You know, have a more powerful magnet. Marshall Blackburn and Chuck over there at Christ Presbyterian Church, they could show people this video of what I've done. You know, everybody at Bellmead Country Club, Hillwood Country Club, they can look at this and go, man, this is theoretically impossible what I did with this battery. And this is kind of like a hit song in the music business. I graduated from Hillwood High School, played on the Hillwood High School golf team. My dad was a member at Hillwood Country Club, and I played golf with Chad Atkins and Archie Campbell, and everybody in the music industry. And when I was a senior at Hillwood High School, I got a job. A friend of mine wanted me to take over this job working at United Artists Records, and I sit around with Kelso Hurston, who was the producer at United Artists Records at the time, and he would always pitching me songs, going, man, what do you think of that, Bruce? And I went, man, I wouldn't buy it. So anyway, one day I'm in the sound shop studio down up behind BMI on Division. I grew up with David Preston. His mother, Frances Preston, started BMI. So I was in the studio with Kelso in the engineering room, and this girl got ready to started singing. And after she got through singing, Kelso goes, well, what do you think, Bruce? And I went, well, you know me, Kelso, I'm going to tell it to you like it is. He goes, yeah. What do you think? And I said, well, first of all, she's beautiful. Second, she got a voice out of this world. Third, she's got the charisma. And fourth, you got a #1 hit there. Well, I don't know who she was. Well, it turned out to be Crystal Gayle singing Don't It Make Your Brown Eyes Blue. Went #1 in country, #2 in pop. Went up and down Music Road that Bruce had the eye and ear for music. Well, this is a great hit song right here. And everybody needs to know about it. You know, it's kind of like Senator Marshall Blackburn needs to show this to Trump. The thing about President Trump is President Donald John Trump. What Trump's uncle was John Trump. And when Nikola Tesla died, the FBI seized all his property, and they didn't know what they had, so they brought in John Trump, Donald John Trump's uncle, to look at what Tesla had. So Trump knows all about this stuff, this free energy stuff, how you can get electricity out of the sky. That's what Tesla did. That's what Dr. Henry Moray did. He built a device, took poles down, ran an antenna wire from one end of the neck, put a ground wire on it, hooked it up to his device, and he only produced 50 kilowatts of power out of thin air. And he couldn't get a patent on it because they, well, where are you getting your power? Well, if you get your multimeter here, connect it to a ground, and then connect it to a wire up in the sky, you'll get AC power out of the air. But anyway, basically, this is a quick demonstration of what I got. There's people out there that are know more about electronics than I do. You know, it's kind of like crazy people built Noah's Ark. The experts built the Titanic. And I just want everybody to know I'm not an expert. I'm just crazy enough to come up with something like this and how it works. And it's just a rough you know, just a little project that, you know, that works, that needs to be taken a little bit farther with someone that's got a little bit more electronic knowledge than I have. Because see, money's not power. Knowledge is power. That's why they spy on everybody. They want to know what you know. So anyway, this is what I got, and that's it. Tell all your friends about this. Show this video around, put it on Facebook, email people, whatever. Thank you. All right, I'm back. Let me show you something else. I have this is cut off, but it's plugged in. I'm using the ground on this, connected my negative to the negative on this. And I got the positive connected to an antenna. I've run some wire. You can't see it. But I got a wire connected to the positive, and as you can see, I'm only getting 109 volts of AC out of the sky with the ground plugged into my socket, because now it's up to 117 volts. Because your house, everything has to be grounded when they do the electrical work on it. So it kind of fluctuates. And I've hooked up a capacitor to this and charged it. And it's incredible. So the point is, this is what Dr. Moray did with his device. He was collecting power out of he called it the ether, call it the air, because the sky is positive, the ground's negative. And this is connected to the negative of the house, the neutral part. The ground, not the grounded part, but the neutral part. So you can get AC out of the sky. Why do you think they have thunder and lightning? You know, Benjamin Franklin, he had a kite. You know, Tesla was born in a thunderstorm. You know, there's power all around us. Dr. Moray called it the sea of energy. It's all around us. But, you know, why do you want to give someone free electricity when you can sell it to them? But anyway, that's just a good illustration of how you can get power out of thin air. And what they did, Tesla, when he built his electric car, he had a copper antenna sticking out, like the old CB radio antennas. And he would take the electricity and he would boost it up through transformers and capacitors. Of course, the technology back then is not like you have today. I mean, look at these devices right there. I mean, they're not configured right because they're all based off of hot electricity. This is cold electricity, but you can boost it up to make a generator to power your house, power electric car. Well, there it is. Now it's 110. Anyway, that's what I just wanted to do, show you that, let you know that I'm still crazy, because crazy people built the ark, Noah's Ark, the experts, like Dr. Fauci. You know, the experts built the Titanic. You know what happened to the Titanic, because, you know, the experts were in charge. Anyway, that's it. Pass it on to everybody. Bye.